Thank you. So good afternoon, everyone. Thanks for being with me for the next 25 minutes. I promise I'll make it as painless as possible. For me, it's particularly emotional to be here at the Computer Museum. Downstairs, there is a PDP-1, which is something that when I was not still on my mother's milk, I could actually understand what it was and partially how it worked. That tells you how old I am. So we're talking today about the automatic provisioning of bare metal systems, specifically for Edge AI. Why Edge AI? Because it's not as the edge that we work through normally. I see there an ex-colleague of mine, Peter. He knows exactly what I'm talking about when we talk about Edge. So a little bit about me. As I said, I'm a strategy lead at the Mirantis CTO office. I am a CNCF and Linkerd ambassador. I'm a very avid OSS contributor that goes from code, the documentation, so on and so forth. I served in the Kubernetes release team with the guy that is down here when he was beating on me a bit, not necessarily in a good way. This talk was supposed to be run by me and by one of the maintainers of Kairos, and that is Mauro Morales, which is a staff engineer, Spectre Cloud, a Kairos core maintainer, also an ex-colleague of Peter and me, and a co-host of the Cloud Native Community Belgium. Unfortunately, for family reasons, he couldn't be here, and he handed off some slides to me, which I hope to do the just honor. So how does traditional provisioning work? What does a traditional provisioning workflow look like? Before we start with this, does any of you has to deal with automatic provisioning of bare metal? You don't count, Peter. OK. Any of you knows what Metal Cube is? And you don't deal with automatic provisioning of bare metal? OK. Fair enough. So provisioning, the way it would look like, we start from up here, right? So we have physically the installation of the system, cabling, racking, stacking, whatever it is. We enroll the machine. In our case at Mirantis, it's a project that is called Cordant. It's an open source project. I promise I have only one slide about it. Then we do something that is called a hardware inspection. So for those that know Metal Cube, knows what a hardware inspection is. Do you guys have ever dealt with OpenStack? Yeah, I'm sorry for you. So the hardware inspection is normally achieved through the bare metal operator inside of Metal Cube. It inspects the features of the hardware, the capabilities of the hardware, and then it prepares the machine and enrolls it. Then eventually we create cluster machine templates inside. I will go through this. We create cluster machine templates inside our Metal Cube. We move forward. Cordant, in our case, and I explain what it is, will pick up the nodes from the inventory that we have generated after the hardware inspection. We deploy the operating system, we install Kubernetes, we hand it off for the workloads. Everybody is happy. How does that look like from a little bit when we double-click into it? So as I mentioned, we use Cordant. Cordant is an open source project. It's based on Cluster API. It's a wrapper around Cluster API. We know Cluster API? Yeah, we do. Definitely more than OpenStack. So the Cluster API is our APIs, Kubernetes-styled APIs, which establish a contract for management, for provisioning, managing, and deprovisioning clusters on different cluster providers, cloud providers. So it can be hyperscalers or it can be on-prem. Then we have Sveltos, which is an operator to manage add-ons on top of clusters which are managed by Cluster API. Sveltos as well is an open source software, is is not under CNCF yet. And we have Cordant. So Cordant wraps around and simplifies cluster APIs methods. If you have ever dealt with cluster API, provisioning a cluster is something between 200 and 400 lines of code just to define what is the bootstrap provider, what is the infrastructure provider, what is the control plane provider. That becomes complex. So we have released in the open source world Cordant to manage all of this. And ultimately, our goal is to manage bare metal. We want to provision and treat bare metal like we're treating cloud resources. Corbin would say AWS clusters, or resource, or nodes. So Metal Cube is a bare metal server provisioning framework, which provides a cluster API infrastructure and control plane provider. It provides using a CAPI styled APIs. There is a cluster API provider. There is a bare metal operator, which talks to the bare metal and does those operations that we saw before of inspection and enrollment. And ultimately, there is a component that those that have done OpenStack know very well, Ironic. So Ironic manages the power cycle of the systems and the provisioning of the operating system, the ending of the image of the operating system. This can be done via Redfish API, hopefully just with Redfish API because it's the most secure API there is at the moment. Otherwise, it can be done with IPMI, very, very insecure, or as a fallback scenario, the last resource, we can do iPXE. So the system boots up and requests to be provisioned. Double-clicking on Metal Cube, I hope it's visible enough. We have, when we have a management cluster, when we deploy Metal Cube, what I would like you to think, the way I would like you to look at this is, we have one management cluster. This management cluster will have certain artifacts, certain definitions that are what is the control plane of the cluster that I want to build, the one that you see on your right, and what is the operating system that is going to be, what is the cloud init that I want to pass the configuration to that operating system, what is the Kubernetes version, and all of these nice things. I can then decide if the control plane of that system lives in the edge system or in the managed cluster or inside the management cluster. And then my worker nodes are just managed like I would do on an hyperscaler, like EKS, AKS, or GKE, where the end user that consumes the service only sees the worker. So I can respect that contract, right? This is what we call remote provisioning. So from the management cluster, goes out, does the hardware inspection, discover the systems, onboard the systems, shuts down the system, and then when you're ready to deploy it to become a cluster, then off you go. However, there are conditions and situations in which the system cannot be deployed by the management cluster, but the system needs to be calling home or calling back, as we say, to be provisioned. So this is a callback provisioning method. We all do it the same way in the industry, to be honest. The system would boot up and will not be powered on, but somebody will power on the system. It will reach out to a DHCP server that can be provided by Metal Cube or not. But anyway, we will have a configuration that is passed through iPXE to say where is your iPXE server and where you can boot. This is the last scenario where we cannot use Redfish or IPMI. I'm assuming that people know what Redfish is. Yeah? Okay. Come again? Yes, that's of course Peter knows. So as Peter says, it's a provision API. So normally when we have a server, just real quick, We have a board management system, card, aka BMC. HP calls it ILO. Dell calls it iDRAC. The rest of the world calls it BMC. That is a computer in itself. It talks to the rest of the world via Ethernet, and specifically via Redfish API nowadays. That's a standard from the DMTF. I know that the TF is task force. Don't remember the first two. But it defines how it presents to the rest of the world what's in that box, how you can talk to that box. Where are the systems? Where is the behind the systems API? Where is the virtual media? What type of PCI cards we have? It tells everything, and that's not always possible. We do not always have systems which have a BMC. So in that case, we need to fall back into this provisioning. That's how bare metal provisioning is done. However, that's not how the edge works. The edge presents a variety of devices, a variety of scenarios, which absolutely do not have these BMCs in place. They cannot be booted like that. So in what we normally would do, we would fall back into the call home or call back provisioning, right? So we would say iPXE and boot up. The problem is that if we're provisioning one of these devices, it doesn't necessarily have an iPXE to call home. It might not have an actual network. It might be provisioned, do the work that it has to do in the place where it is installed the device, and not having a network somewhere. Now, this image was generated with AI, and as you can see, I don't know what's that car there. So, but anyway, whatever. It's an edge device. So that's a problem that we have. So the remote-based provisioning does not work in this scenario. The call-home provisioning, most of the cases shown here, do not work. So what we can do, we have, now let's pause that a moment. We have, from the Edge AI and Vision Alliance, Jeff Beer created this framework, this tool that has an awful acronym, and it's called BLURP. I said it. So these 5 factors are very important to determine the trade-offs that we have to make to do AI on the edge. Bandwidth, we need to use the bandwidth consciously, so meaning that we can't be chewing data and send the whole data set back, because we might have very limited bandwidth. We might have bandwidth that is shared with other services. Imagine a boat in the ocean, right? Or an oil drill, an oil rig. I'm sorry, they still exist. Those systems, I've worked on projects that are involving those systems. And when they were not drilling, their connectivity was 15 megabit to the shore for all the services on the rig. And when we have 15 megabit, you can't be so arrogant to use all the services for your edge platform. There are also other things that have to happen. Latency, at times, is very high if we still have the network, I don't need to say. And economy or energy. So when we talk about economy and energy, we need to be cautious of the cost of that platform. On rig can be power, the power cost. We have to be very conservative. And being very conservative is trying to use the best hardware for the equipment, but also the best software for the job. Reliability. I love that in the blurb, there is nothing about availability. Because, going back a second, how can I guarantee high availability on a drone? Or how can I guarantee high availability on a satellite or on a 5G antenna? I can't double the systems. I can't quadruplicate the systems. So in the blurb, they don't talk about availability, they talk about reliability. So the system needs to be reliable enough for the time that it's working. If there is an outage, the system should not be necessarily affected. or if it is affected, there are things that we need to consider. Privacy, the system is at the edge. So that means that it's not in a data center secured with, from people like James Bond with an iris scan and vein scan. So the system needs to guarantee that if it's stolen or if it's accessed by a third party, we should be able to guarantee that the data are not going to be affected and they're not going to be stolen. So when we look from a workload perspective, there are certain, and we don't, are there developers or data analysts here? No, perfect. So we skip this slide. So when we're talking from a workload perspective, there are certain things that workloads need to be able to do. I need to be able to process the data at the site. So, and that's the very definition of the edge. Data as close to where they're consumed as possible. So data consumed at the site and not streamed back, because not always there is the bandwidth, not always there is the latency, not always there is connectivity. Decide to hit real-time deadlines in place. The economy, cut the customer and power, send insight on. It's just saying over and over the same thing. On the last part, the privacy, I want to go back to the next slide. So because of this, because of the workload perspective that we just said, then we that build the systems that are going to host those workloads, we should have a contract like we do with our APIs. So the Edge platform should establish a contract with the consumers of that platform, which are the developers, which we are not going to stream the whole deployment to the platform because we don't have that bandwidth. So those methods that we saw at the beginning, we cannot necessarily do it. There should be a zero-touch provisioning of the platform. Because of the latency, that we are not going to be able to, remotely deploy the system. We should be able to hand off the provisioning media to the person that is going to be on site and say, hey, just run this and everything is going to, and leave the site. Everything is going to be fine. I know what's going to happen. I'm just going to skip to the privacy. The privacy, we need, when we build that platform, we need to be sure that if a third party accesses the hardware, what we always say, right, is secure until somebody goes there and can put their hands on the hardware. Well, we need to provide that security as well. We need to guarantee to the people, to the consumers, that if somebody comes around, they cannot touch anything, they cannot do anything. It's just a piece of metal. And there are ways to do this that we're going to see shortly. So what is the final part of this? Image-based provisioning. So this is the third method of provisioning, which is not initiated by the management cluster, not initiated by the system, but initiated by the user. For this, we use Kairos. Kairos is a framework, is a purpose-built operating system, and is a framework for building Linux-based immutable systems. For the security, for the privacy that I said before, Kairos by default supports trusted boot with TPM, so it encrypts whatever you have on the hardware, and you cannot boot another operating system. Without the key that is burnt into the hardware, you cannot boot anything else. It's a container-based distribution, or meta distribution, and supports a cloud init-like configuration, and it is a sandbox project. We at Mirantis, we have contributed K0S, namely me. I've contributed K0S into Kairos, so there are different flavors of Kubernetes that are deployable. The way it works, Kairos, once it's provisioned, the systems become immutable. However, we still need to handle upgrades, right? So if we go on site and we want to upgrade the software that is running in there, we need to, Kairos handles this with A/B upgrades. So it has a persistent area, which is the data of the customer, of the user, configuration area, and then we have a recovery and active-passive area. In the active-passive area, we can pass a new a version of the operating system that you're running or a new software version. We boot the system in the B, and if everything is going okay, we have the A version still underneath to revert if needed. This is nothing new. We do this since, I want to say 20 years, but it's not true. We do this since many years in the industry. So how does it look? Kairos is a container base. So basically, we decide what operating system to use. We can use Ubuntu, we can use OpenSUSE, Fedora, whatever you want. You can also use OpenRC-based systems. Define the items that need to be in that Docker container. Configure your cloud init. I put in the QR codes here for you guys if you want to grab those configurations. But you configure the cloud init. You pass to Kairos what needs to, from where it needs to take the base image, if there is a base image, or if it doesn't have to have a base image, you can just pass the configuration. You can pass what type of Kubernetes we want to have. In this case, K0S. We want to have it enabled, and we want to have the arguments, blah, blah, blah. Then we can create a bootable media, and that is where the user-initiated provisioning comes in. We are with Kairos Factory, which is nothing else than a GitHub action. We can initiate a workflow to deploy local AI. That's the AI part, right? So we built the system. In this case, we are building Kairos Ubuntu 24.4 and K0S. We are deploying we get our image, and this one will get burned into an ISO. K0S is very interesting from this aspect because it has a deployer embedded. So there is a directory that if we drop in OCI artifacts, we can, K0S will pick them up and will deploy them in the cluster. This means that I can prepare my ISO with all the artifacts at my office, at home, prepare the ISO, give it to the person that will go deploy the hardware on site. When they boot up the system, it will boot up a couple of times, and the cluster will be running with the workloads that are needed to be running, because a cluster without workloads is useless. In this case, the workload is local AI that I wish Mauro was here because he had the demo running, but in this case, the boot can be done with a USB, as I said before, with a net boot directly from Kairos, or from a remote Pixie, which we said that we can also not do. And we have local AI running. So local AI, in this case, would be running on the cluster that is disconnected from the internet, meaning that we can do inference in that place. Imagine wildlife preservation, we want to see the behavior of a certain species that is in danger for some reason. We are not going to have network over there. We are not going to have too much human interaction because that wild species might not be showing up. But that system that is there, that camera is observing and is collecting data and is making assessments. And every once in a while, we can gather that data. So that's interesting. And these are so local AI, as I said, it's also, sorry, I didn't say that, but local AI is an open source project as well. And you are more than welcome to try it out. You can run it on small systems or large systems, but it's absolutely fun to use. And you can go from experimenting in your own lab to actually deploying on sites like we do. These are some QR codes. There are no viruses that I know of, but I don't promise. This is the GitHub action to create your own Kairos labs, like Mauro has created with local AI. This Cordant, some information about Cordant, local AI, and Kairos. So I'll leave it a moment there if you're capturing. They're capturing. Ray is looking at me because there is too much silence. I could talk about me in the meanwhile, which is always an interesting item, but I will avoid. OK. And that was all I had. I can take 30 seconds of questions? Or not? No, I cannot.
Yeah, they have a booth here, and will be here.
Oh, yes, absolutely. Yeah. We have a booth out there. I'm always around. I'm me with this face, and I'm out there. Thank you very much.